Okay, I'm going to do some more derivatives in section 2.5 here, but now we're going to use the generalized power rule, which, by the way, the chain rule is a nice rule we needed for certain problems, but the generalized power rule is something that's kind of a simplified version of the chain rule that we can use in almost all of the same circumstances. So I'm going to go ahead and look at that now. This is a derivative, this is a function which we just looked at in our last example, but just to show you we can use this other rule, the generalized power rule, or we can compute the derivative of this function using that rule. Okay. So right here I have kind of a short version of the generalized power rule. And it's not a very complicated rule, but you have to kind of understand what it's telling you. It's saying if you take the derivative with respect to the variable x of u to the power n, okay, so what's u? Well, that's the great thing. U can be any other function you want. Okay. So if you have a function raised to a power, a whole number power, okay, or any integer number power, okay, as long as this isn't some other function. If you have a function raised to a power and you want to compute the derivative of that, you bring the power down and you decrease the power by 1. Sounds just like the power rule. Okay. But then if this isn't just x, if it's any other function, you have to multiply by the derivative of the function you are raising to the power. Okay. Actually a very quick rule to use in a lot of the problems we have, and we'll go ahead and apply it here. Okay, so first of all, what about the derivative of this function? Okay, well, we're actually ready to use this rule. This is just simply a function raised to the power 5. Okay, so the generalized power rule says if you want to find the derivative of a function raised to the power 5, the first thing you do is bring that power down, okay, times the exact same function, 4x plus 3, to the power that's 1 smaller. So that's going to be 5 times 4x plus 3 to the 4th power. Okay. However, we have to multiply by du dx. That's just the derivative of the function u, the thing we were raising to the power to begin with. Well, the derivative of 4x plus 3 is just 4. Okay. So I've got 5 times 4x plus 3 to the 4th times 4. And just like I did in the last example, I can multiply the 5 and 4 together, and I get 20 times 4x plus 3 to the 4th. Okay. Same answer we got in the last one, just a slightly different rule. Okay. Over here, another example of using this generalized power rule. Okay, so we've got a function which is called y. We want to find the derivative. We can write dy dx, or just call it y prime, but we need to compute this. So we're asked to find the derivative with respect to x of this function. Okay. Now when I write this in here, I'm going to go ahead and make one rewrite step. This is the cube root of 3x squared plus 4x. Okay. Well, that's the same thing as 3x squared plus 4x to the power 1/3. Okay, a cube root is also the power of 1/3. Okay, and actually, now that I look at it, I have the problem wrong. This was number 34 in the book, so I better make this change. So the cube root of 3x cubed plus 4x. Okay, yeah, I thought something looked a little fishy there. Okay, well, it'll be about the same problem anyway. But now, well, again, we're set up to use the generalized power rule. We're taking the derivative of a simpler function raised to a power. Power rule, the generalized power rule says, when you're doing that, take the power down, so 1/3 times the original function that was inside, 3x cubed plus 4x, okay. Make the new power smaller by 1, okay. So 1/3 minus 1 is negative 2/3. Okay, I'm going to be careful there when you subtract to get a negative number. And then we have to multiply by du dx, the derivative of what was inside. Okay. Well, the derivative of 3x cubed, again, basically, a couple of our basic rules are used there. It's going to end up being 9x squared, okay, 3 times derivative of x cubed, 3x squared, gives us 9x squared, plus derivative of 4x, which is 4. Okay, had a little knock at the door there, so I had to take a little break. Basically, we're done with this problem. We just need to kind of simplify things. In the back of the book on one like this, there are a couple of things the book was always going to do. For instance, what about this power? Well, it's 1/3. We've got 1/3 times this stuff to the power negative 2/3. So we can write that as 1 over 3x cubed plus 4x to the power 2/3. Okay, which is also the cube root of that quantity squared, okay, times 9x squared plus 4. Okay. And basically that's going to be the final answer. Probably the only thing they might do differently in the book on this one is write the derivative as a single fraction. So they would say that for that function y, dy dx is, so like 9x squared plus 4x, sorry, plus 4, okay, over 3 times the cube root of 3x cubed plus 4x, that whole quantity squared. So that looks fine for the final answer.